Underwater volcanoes are an ever-present danger to those who sail the seas, but for the most part, they're not something we need to worry about because most of them are very unlikely to blow. You would have more luck getting struck by lightning or being trampled by a rogue elephant. Even so, every now and then a volcano does erupt underwater, and it can cause some serious problems for shipping and for us. But there's another kind of underwater volcano that is far scarier than your typical magma-spewing mountain. They're much less common but could do far more damage. These are supervolcanoes. And while you may never see one erupt in your lifetime, you should still be worried about them, because they don't just threaten people living nearby, they threaten all of us who live near oceans. There are only 12 confirmed supervolcanoes on land, but we know of at least 36 underwater. And we haven't even explored enough of our oceans to say for sure how many there are. Of course, since supervolcanoes are so rare, trying to find evidence of their eruptions can be difficult. Sometimes we don't even know when they go off until years after the fact. So we definitely don't know the true extent of the damage that they can do. But before we get into what their eruptions might look like, first let's go over what makes a volcano super. Well, the technical definition is any volcano with a history of multiple eruptions that eject more than 1,000 cubic kilometers of material is considered a supervolcano. This amount of erupted material is called the Volcanic Explosivity Index, or VEI. So anything with a VEI of 8 or higher is considered a supervolcano. For comparison, Mount St. Helens had a VEI of 5, and it caused billions of dollars worth of damage. So imagine what an 8 or higher could do. For supervolcanoes, the larger the number, the more catastrophic the eruption tends to be. A VEI 7 eruption is considered large and can send ash clouds 40 kilometers up into the atmosphere. A VEI 8 is considered massive and can send ash 100 kilometers into the air. Anything higher than that is extremely rare and hard to measure because there aren't that many examples to go off of. Luckily for us, supervolcanoes are pretty uncommon no matter where they are. And so far this century, none have erupted, although there are a few that scientists are keeping an eye on. Like Mount Ibu in Indonesia, it had a huge eruption in 2021, and while it hasn't reached supervolcanic levels yet, it may in the future. In fact, scientists predict it will probably erupt again soon. The biggest recent supervolcanic eruption happened back in 2018 at Lake Manoun, in the Democratic Republic of the Congo. It had a VEI of 8, and researchers estimate that it ejected 300 cubic kilometers of ash and debris. Thankfully, it was far from any populated areas and didn't cause any casualties, but it did send ash as high as 35 kilometers into the atmosphere. And while that may sound impressive, it's nothing compared to the largest supervolcanic eruption we know of. That title goes to the eruption of Lake Toba in Indonesia around 74,000 years ago. It had a VEI of 8, and experts believe it ejected somewhere between 1,700 and 2,800 cubic kilometers of material. In fact, this eruption was so big that it created a lake, now called Lake Toba. It's actually the largest lake in Sumatra. But if you think that sounds huge, the eruption of Mount Mazama in Oregon around 7,700 years ago was estimated to have been between 2,800 and 3,300 cubic kilometers. Today it's home to Crater Lake, which is the deepest lake in the United States. So it's clear that these eruptions are capable of some truly incredible feats of destruction. But what happens when a supervolcano erupts underwater? To answer that question, scientists look at the only known underwater supervolcanic eruption that we know of. It happened at the Hisutori Caldera in the Bering Sea around 6,300 years ago. The eruption ejected an estimated 350 cubic kilometers of material, making it a VEI 7. Unfortunately, we don't know what the eruption looked like because there were no eyewitnesses, but we can make some educated guesses based on the geological record left behind. After the eruption, hot water vapor and gases shot straight up through the seafloor, creating new features on the ocean floor called dome mountains. Hot pyroclastic flows rushed out from under the water, cooling quickly and hardening into pillow basalts. And unlike their above-water cousins, these underwater lava flows don't travel very far. Instead, they form into piles near the volcano. and instead of ash raining down from the sky, fine sediment rained down and formed layers on the bottom of the ocean. What's more, the energy released by the explosion likely triggered giant waves that radiated outward from the epicenter. Researchers estimate that these waves may have traveled as far as Japan. Now, obviously this eruption wasn't a VEI 8 or higher, but it's the best evidence we have of what a supervolcanic eruption might look like underwater. And it tells us two important things about underwater supereruptions. First, the water likely weakened the force of the eruption itself. Second, the water column likely played a huge role in how the eruption unfolded. In fact, it's thought that this eruption may have started on land as a normal volcano. But as it grew taller, it eventually reached the water's surface. As it continued growing, the water pressure actually began to weaken the magma chamber below it. Eventually it became unstable and blew. Now, scientists don't think that this is the way that all underwater supervolcanoes erupt. In fact, this particular volcano may have been an outlier in other ways too. It's possible that this eruption deposited more material on the seafloor than others because it emptied its entire magma chamber during the eruption. Most volcanoes don't do that. Instead, they have magma replenishing the chamber as it empties. This means that they can have multiple eruptions that are similar in size. For example, Mount Ibu has had several VEI 7 eruptions. So if we want to better understand what a hypothetical underwater supervolcanic eruption would look like, we need to study volcanoes that repeatedly eject similar amounts of material. In 2021, scientists took a closer look at a volcano called Cavaci, also known as the underwater fire. Located in the Solomon Islands, Cavaci had several eruptions between 1950 and 2020. These weren't huge eruptions, though. Each eruption had a VEI of 4 or 5, but it gave scientists a good opportunity to study how underwater volcanoes behave. Using unmanned vehicles equipped with cameras, they explored the caldera and were shocked to find active vents spewing out hot water and steam. There was also evidence of recent explosive activity, and while they didn't witness an eruption, they found features like raised areas called humps and new rock formations. But perhaps even cooler, they discovered a whole ecosystem thriving around these vents. There were squat red sea cucumbers, ghostly white corals, and even fish darting in and out of holes. Clearly, life finds a way to survive around deep-sea volcanoes. But what happens when an eruption gets bigger than normal? A 2021 paper lays out a hypothetical scenario for what a VEI 8 eruption at Cavaci or a similar volcano could look like. First, the eruption starts out small with lava flows moving out and away from the center. But as more magma is ejected, the intensity increases. Ash and rock begin to fill the water column above the magma chamber, forming a massive ash cloud. The pressure inside the magma chamber continues to rise until it overwhelms the strength of the seafloor. It erupts violently, sending a giant pulse of energy outward. This energy generates huge waves that spread across the ocean's surface. At the same time, the pressure from the eruption causes water to rapidly boil and turn into steam. This further expands the size of the explosion. Meanwhile, the intense heat melts rock and metal, creating a cloud of pyroclastic material. As it rises through the water column, it forms a mushroom cloud that eventually breaks the surface. Unlike above-water volcanoes, submarine eruptions don't generate pyroclastic flows because the surrounding water quickly cools the lava. Instead, the eruption forms new islands of solid rock and sends material raining down on the ocean surface. This material eventually settles out, creating vast piles of ash and debris on the sea floor. As you might expect, the effects of such an eruption would reach far beyond the immediate area. The giant waves generated by the explosion would carry energy around the ocean basin, causing coastal flooding and erosion. The wave energy would eventually dissipate, but not before impacting marine ecosystems along the way. These impacts would depend on how far the waves traveled and how strong they were. For example, in 2018, the magnitude 7 eruption of Mount Ibu generated waves that were detected as far as Australia, over 3,000 kilometers away. While there were no reports of significant damage, scientists did detect changes in wave activity along the coast. If a VEI-8 eruption were to happen today, major shipping lanes would likely be shut down for weeks or months. The fishing industry would take a huge hit, and tourism would likely decrease. It could also disrupt global food supplies and raise costs for everyday items. To top it all off, the eruption itself would likely release massive amounts of greenhouse gases into the atmosphere, potentially speeding up climate change. While a VEI-8 eruption is unlikely to wipe out human civilization, it would certainly cause major headaches for our economy and our daily lives. That's why scientists are working hard to monitor volcanoes and better understand the risks that they pose. Hopefully, with enough research, we can stay one step ahead. Thanks for watching this episode. If you liked learning about underwater volcanoes, you'll probably love our podcast. In it, some of the brightest minds in science come together to talk about the most intriguing topics in STEM. Each week, you'll get to hear fascinating stories and insights that you won't find anywhere else. All the links to listen are in the description.